Ladies and gentlemen, Masonry is here, and today we are going to be working on the burner control and more importantly the electronics, and going to clean up the mess of wires that we currently have, eliminate a lot of wires completely, and eliminate a lot of useless long unnecessary connections and all that kind of stuff by using the protoboard and soldering everything onto it, because suppose it is now working fine. And the other thing that we want to do, if we have still time today, is that I'm going to work on the quite heavy going to work on the stepper screw position feedback. Looks kinda, it can wiggle a bit, but regardless, we'll work on this today, and we'll debug him because the code probably contains some errors that need to be debugging. But yeah, we'll be working on him as well, hopefully, if we have time. If we don't, then I suppose that's it for today. Okay. So without further ado, I will reposition the camera to a more appropriate position, or we'll need to think a bit. Yeah, probably we'll take this position here. I have to set the whole thing up a bit. Sorry. Okay. Rotation. Decreasing, and probably fine. Okay. So we have a lot of garbage here. We'll need to tidy up a bit, but I suppose that's for another day, or maybe later, but I don't think so. So yesterday we have worked on the thing. Now I will take it off its place, and then going to solder, or like not solder, but like yeah. As I have put it into its place. Yeah, I will need to take it off, because I would like to solder the extra things onto it, which will not work. Yeah. So first creating like a drawing, so that I'm not in the frame, I know. Just thinking, I need to create a picture, or like a document on how it's supposed to be connected. We'll put this to the side. Create a paint 3D, I suppose. Docs, I mean, we can keep it in here. But what is this? I think it's the chopper. We'll call it what's the name again? I think it is called TF or FT. We call it FT 202101 Toch, but going to call it this TF, whatever. So this is the name. I don't know what this thing is. So we have the board here, and might not need it. Sit up properly. So we have a few pins. I would say this sized. Put them here and make the canva a bit bigger. So, oh fuck. So 1, 2, 3. It's not going to be perfectly straight, but I don't really care. 4. I care about the documentation rather than the aesthetics that we have it. It's going to be useful to have this because I'm sure maybe drawing would be better, but at least this will be with us for quite some time. Make this more disgusting, okay, then don't scale it up. Put a thing here. Put the little circle into the right top, left top. I think it was there. No. Come here and check. I think it is like this. Yes, it is like there. And the first wire is, yeah, the furthest, so the right on the top side is the power downwards, and we have actually one ground and a, so the PWM output is the left bottom corner, so this is PWM2. So PWM, I mean, we will label it Rubik. Make it a bit smaller, make it like 26. So we will call it this 1. Call this 1. 2. And technically we can do this, doesn't matter. 1, click, 2, 3, 4. Fuck. Maybe not the best time on invested, but I suppose it needs to be done. 5 I say. Fuck. 6, 7, 8. Is this, yeah, 8, okay. So we have capacitors that are, yes, we have a, God knows what this is. We have 2 caps between the power and the, I don't know what this is, so I should have fucking written this down somewhere. God damn it. The little one is a 100 nanofarads, that's for sure. And yeah, we take off the, we have the green in between of them, which is the green. So the left one is the ground, then we have another ground next to it, so ground, PWM, ground. Yes. So let's create a 1, 2, 3, 4, 5, 6, 7, 8. Okay, create the list. the one is the PWM out, if I'm correct. Yes, PWM out. The 2 is GND. 3 is none. 4 is none. We have then 5, which is the power, I think, 12 watts. 12 watts. We also have the ground next to it, GND. Then we have, this is the PWM in, this is the out. Fuck you. And 8 is the GND as well. So this is the labeling, I would say. And we will also draw a few things here. So we have a fuck off. So we have 2 caps between, come on bro. We have 2 caps, we'll have to make this smaller. We have 2 caps, so one here and one here. Alright, we're going to have this connected here. Okay, this is going to be 100 NF. The other one is, I have no fucking clue whatsoever. Maybe we will check on the, maybe if they have anything. But I am not going to be too of course it's not here. We hope that there is any is there any instructions on to which things to use? Don't care about this. I suppose that there is no instructions then. Fortunately, can't fucking remember which doc I have had to fucking. I should have written this down. I can't remember which it was. Oh, yeah. Oh. not the best. Though, if I could go, if I could take time in the battle, the first thing I'd like to do is to save every day for eternity spent time with you. The question is that we use this one or the other one, 1UF or 110NF. Good question. Maybe no, none of them. Which is this? So we got this after this. Oh, I can't remember which it was. If I used it from... No, I don't think I have used it from this. I think it is from this. Or maybe here. Did we buy any? Maybe. I don't think this is it. I don't think this is it. 100NF. I have though 100NF. It's just... yeah, because these are as well as 100NF, but these are very small. I think this is not 7X. Oh, it is. 100NF. I have no fucking clue. 1UF. We'll have to check. No, I can't see the number on it. That's the sole problem of the whole thing, is that I have no fucking sight on the... The first thing I'd like to do is to save every day for eternity. Just to spend time with you. K5K. I don't know what this means. Have no fucking clue. Yeah, this would have been so much better if I had any fucking clue, which... honestly, I don't have any clue. Sad. By the way, we will come in, we can do this, we'll write the big X onto it. I have no fucking clue how much it is. X and F. Alright, we'll have to correct this later on. For now it is fine. Better than nothing. At least we now know what to expect. We'll put the thing in here. Just need to cut it off of the board. Well, I need to remove it from the... Hope I don't break anything while doing the removal. I mean, I can show this as well. Also, the problem currently, and I might solve it with the little organization. We have this lovely this thing, which is basically I don't know if it fits. We'll cut it. Don't want to fuck with it too much. So basically these are these guys. Is it hard to get one out? Yeah, I suppose. Okay, good. So basically these are markers. You can take them out. And these are the fucking all these are connected. Okay, fine. So basically the guy is this. You can put it onto the wire itself. You clamp it there. I mean, these are obvious. Now these aren't too obvious. We put this is going to be the 0. This is going to be 0. It's a bit tight on the line. This is annoying. These are obvious. Yeah, these are obvious. So the two blue fuckers. I mean, this is obvious as well. These are not too obvious. Don't want to figure which is which. Suppose. Yeah. You know that this is the voltage divider. This is the white is bot. That is the signaling. We'll move on. Taking these off. We'll be able to put, so basically from right to left, 0, 1 and so on. So removing these. This is the motor shit. This is the voltage divider. Coming off a bit easy. Power and ground. So yeah, we have removed everything. So here it is the board currently. The motor controller for the stepper and voltage divider. This is the stepper's position feedback thingy, output, whatever. So trash is out. We'll get to do the prototype designing. Oh, I did not change to. Oh, I'm terrible. Fucking hell, man. Bad. Super bad. Almost terrible. Yeah, I did not scale this up, did I? Oh, fuck me. Whatever. What fucking ever. So what we do need is that we are going to put these two chips here. I didn't show, but well now scale this up. Come on. Alright. So basically we have these here. So come on, this and this little board. These two are the low side switches, which basically control the MOSFETs. The PWM generation is starting from the board, but we need 12 volts so that we can switch the MOSFETs, so that we are in the not in the linear region but already saturated, and that way the switching doesn't heat up the MOSFETs, because one was killed because just of that. So I need to scale this up a bit. Right. It's the chronic, how do you say this, cluster, I would say, chronic problem that the I think it's kind of like could be a law that if you have any, like, let's say you have like a table or something, and you can have it as big as you want, but after all you are going to put it with, like, stuff it full, and you will need to clean it up eventually, because you can have as big of a fucking desk as you want, it will be always full. It will be always kept full. So yeah, this is what my biggest concern is right now. So besides that, we'll need to make the thing. I will need to gather my tools and my things here. So I have these leftovers. This is basically, these are the female connectors, if I can get it out of the box. No, this is the long one. I think I had a short one somewhere again. This is a 4 long. We'll need to crack the thing off. Probably we'll make a 4 one out of 2, 6. These are 2 6s. Yeah, 2 6s. And we'll need to somehow make a good one from this. Yeah, I could have bought the 4 ones. I probably should have. They cost more, but I'm not going to fucking bother with it. I'm not going to buy like 10 of each, maybe 20 of each. It's like 100 forints or some shit. Negligible, but I was a bit cheap ass, so I might have how do you say this, regretted that decision of mine. I will need to find my fucking tools. I don't know where my plier is. Here it is. I never figured it out what to use this, or what to use this with, because if you have 4, basically the current problem is that you need these female rails, so that basically I can put the one female rail. I need to break this plastic shit all the way. So we put the plastic shit in here, and then we can sit the board just like this, kind of like shield. We can remove it at any time if you wanted to, and then we will of course not put it there, but somewhere around here. We'll need to take the board off of there. We need to figure out which lines it sits into, or like rosters it sits into. But then we are going to add the necessary jumpers and all that garbage, and then that's it, I suppose. And we'll need to make it 2 times, so basically we will have it once here and once here. So yeah, first I'm going to break the leftover things from here, hopefully not break the other thing. Because I was not skilled enough, and I broke the thing out. It's kind of like a V-tapered thingy. I hope I'm not going to. Kind of like, I don't know what this is. Let's say Bakelite or Bakelite, I don't know how they call it. Probably. It's not thermoplastic, that's for sure. So, what the problem might be, first of all, is that I'm not sitting. Second of all, need 4, but I have learned that the hard way, that you always want to have 1 more and cut it after that. You can break it off, or you can use it, but I will probably break it off, because the problem is that when you cut it, you can fuck the Yeah, it's hard to cut it in between them, so it will probably fall off. Of course, I will need to put something over it so it doesn't fly out of the world. Okay, that does it. Oh, I was good enough to cut it for 5. Oh fuck. Yo. This got to be pretty good, and I actually broke the next one, as you can see. That's what I'm saying, that when you cut it you will lose one, because this is hard to cut, not meant for this probably. But we're gonna cut a 4 one then. We'll try with the 4 one. Let's see if we have any luck with it, or like if we are good enough, or like I hope we will be. Nope, we weren't. We got a 3 one. Not too good. Not too good. Let's try the 4 again. We'll have another 3. I will just use the 5 and break one off. I don't care, I'm not going to waste any more. Plus I can't really do this, my hand is not really healed up for this type of cutting shit. Another 3. Oh my fucking god, come on. Then we are going to break one of this shit. Fine, fuck you. What is this? Shut the fuck up. Just curious, if I take this, and I also take this, can I break a 4? Again, it broke in the fucking pin. Okay, I get it. Then we will get to 5. Fine. Made like fucking 4 3. Oh my god. What a disgrace. Got 2. Great. Very well. Congrats on that. Out of how much? 1, 2, 3, 4. 25% success rate. Not too good. Aye. 2, 4, 5. Let's break it here then. Yep, this is circle as well. It's fine, because these shits fall out, have nothing that holds them in. Okay, fine. So we have a 4 and then, great, we need another one. And then that's it, basically we ran out of rail, not too good I suppose. Oh, this is barely fucking 1, 2, 4, 5. Yep, that's it for this as well. Basically trash. At least we now know. The remaining, these are the little things. Of course you fall out. These are the things that you probably can't even see it, can you? Ah, you can see it here. Right there, these little Poseidon shits. Breaking off the remainders. Please don't fuck. That doesn't look any good. And looks terrible actually. So we'll buy a lot of these next time. It's going to look terrible, but I do not care. I do not care. I care about functionality, not looks. I do not care. So you'll need to take off one of these. Cut the guy off the protoboard if I can get to it. Yeah, that's a bit of a problem. I would add. Oh, fucking hell, I have glued this to the board like hell. Anyway, so give me a minute to cut this bitch off. I'm getting a stroke here. Hold on. I can show how I'm fucking struggling here. I have no space whatsoever. I mean, from here might be able to, if I take off a few guys. Nothing is fast and nothing comes easy. Oh, great! Finally. Good. And put this somewhere safe for stiffing over the turn. So from here I might be able to cut the guy off. Patient enough. I didn't fucking save or like spare on the didn't cheap ass here with the fucking glue, I suppose, and put a lot of it here. Come on. Apparently it's easier to pull the glue off of it than to cut it. I mean, if you want that way, I mean, I'm down. Come on. Fuck off the board. Wood. Do not need this here. Can fucking. Will you come off? Good. Oh, great! You fucking took a piece of the board as well, but I do not give a fuck about it. What I am going to do is to. Oh! The whole thing was not recorded. I'm going to shoot myself in the fucking head. Sorry. So, I mean, honestly, I should fucking look at where I'm recording. I'm so fucking bad at this. Pissed off. At least I got this fucker off. Unfortunately, did not record it. Fuck. Please, this shit gets off. Okay. Regardless, I remember how much pain I had with these little fuckers. So, yes, we have one of these fuckers removed. We need to remove the other one as well as like to remove the fucking wires so that I can salvage the capacitors. So this is the order. I mean, both of them will need to be taken down. Let me take the screw here. If I think I have it here. Yes, sir, we have it here. Wait a minute. If I could get it out of the fucking bin. Okay, fine. So we have the orange E's, and now I have been saving some screws with the thing. Salvaging this swallow as well. Not need you. And we do not need this screw either. Put this back to where it was. Removing these. Okay, we have this guy here. I'm gonna take this as well. Plus one wobble again. We can remove the jumpers. How much time I have spent with this shit. Fine. We'll every fucking wire is in the main. We'll need this without breaking the caps off of it. Come out. Oh, I need to take this off as well. Great. god, again that I have used the same burner. Alright, come out please. Put this back onto the table once, and you need the other board removed. We'll need some space here. Create some space. Trash, of course, trash everywhere. There is no space. Ivan! Wait a minute. I need to inspect the dog with the new outfit. Azért událtak? Te a cuccod, baba? Nem kellene ugatnod azt, hogy hoz neked ajándékot, basz meg? Vagy ugyanilyen volt elányadva a kabátján a kis. Jó, ja, soroztunk. What the fuck? Mi ez az oszta? Másik sem. fucker. Removing the fucker. Removing him. Hello. So yeah, cutting off this garbage. This is the low side. I mean, this is just a sort of cheap ass protoboard. If I were to be professional, I would use like a metal enclosed box. I mean, I want to use that, just I didn't want to know that there is like these boxes are bigger than this PVC, I don't know what these are, ESA. What I'm working on is that I will remove this thing, and then after that I will clean up the whole thing by have these falling stuff is falling apart. So I have this protoboard here, and I will add these little legs onto it, and basically create a sort of shield, kind of like with this, as you can see, and then it will be nice and clean rather than having this garbage all over the place. With this we will be integrating all this. Basically, if you don't know this, it's Ringer, and I'm working on a burner project, and these are the automation stuff here. This is the controller board. We have the STM32. I mean, I don't know if it is good electronics, but I suppose it is working. This is the STM32. This is the controller board here, this white guy. This is the chopper board. I made it myself. This is for to control the blower for the burner as well as the fuel pump. Basically, we can generate a PWM code in here, and through these little things that I'm basically replacing right now, we are switching the MOSFETs so that we are not using the 3.3 volt but the 12 volts from these boost bars, and that way we do not overheat the MOSFETs, because I have had one MOSFET die on me because of the what do we call it? If you don't know about it, there is like, or know about it, the MOSFETs basically have like a, I'm just going to, like, very poor man, have like a plot here. Imagine that when we are adding voltage onto it, it's on the gate, which is basically that to open the MOSFET between the two legs. So there is three legs of the MOSFET. There is a I think it is whatever, it doesn't matter which one is which. Gate is what you add the voltage onto it, that basically enables to conduct between the drain and the source. And when you add voltage to it, the drain and source, the source starts to conduct, meaning that you enable the circuit, and that your devices will basically energize on that. But the problem is that when you add very low amounts of voltage, it is like characteristics per given MOSFET, how much voltage. It's kind of like a gate or like a valve. If you do not fully open the valve, there will be some resistance in the valve, and when that resistance is high, basically as you open the valve, the resistance decreases. When you have the gate fully closed, then, or not at any voltage, then it is closed, meaning that you have infinite resistance in the path. If you add more and more voltage to it, increase the voltage, then it becomes more and more open, and it has like a linear characteristics. It's called saturation. And when you apply enough voltage that it is fully open, has the less resistance, then it heats up less, because resistance creates like heat. And when you have not enough voltage, like here in the STM32, which outputs like a 3.3 volt signal, then you have a lot of resistance still, meaning that at low PWMs, when you have the PWM is basically like having a rectified signal that basically having, imagine 10 seconds of on and 2 seconds of or like 10 seconds of window, you have 20%. That means that you have only 20% of the whole 10 seconds, which is 2 seconds on. And this is done basically like 25 or 20,000 times per second, so it is very fast. But when you have very low amount of PWM, meaning that your thing is very low, and you have a quick on, and you have very little periods that you open the whole thing, that will create a fuck ton of heat, and that will basically fry the whole 12 volts, but it can basically, I think it is rated for 50, I think it is rated for 50 watts or 60 something. It's a lot. Both of them are rated for they can run on 24 or 12 volts. It doesn't really matter. I designed the both. I think the MOSFETs are capable of running on both 12 volts and 24 volts. The problem with the 12 volt side is that it has, as you can see, the bulb caps are bigger on the 24 volt side than on here, so that's why it is rated. But I think both can work, but I'm not sure. Yeah, I do a lot of lives. I usually just do boring stuff, so to speak. I usually solder or like tinker around. I'm currently struggling to cut off the hot glue that I have put in between the cardboard and the board, so that I will need to somehow crowbar it off with this knife. Cut it somehow. I will replace this board as soon as possible. We put it into a metal enclosure, just as I showed, just that was plastic. I'll show it. Thank you. I mean, I'm probably not the best electronics guy out there, but I do learn as I go as well. Need to learn these, because otherwise I will not be able to do the projects. These require a lot of stuff, and there is remove the leg of the chopper board itself as well. Not too good, I suppose. I created a big crater into it. Whatever. I'm going to remove all this cluster of fuck here. Salvage this. This is just a shitty Wagyu setup. Use like jumpers and all that kind of garbage. Didn't have better solutions back in the day when I made this. Currently I have upgraded my toolset a bit, so that I will be able to make more stuff, or like better stuff, I'd say. So, oh come on, wire. So I need to put the, it's visible. I need to always check, because I'm usually like distracted with doing stuff, and out of the frame as always. God damn it, I need to remove this. Where is the trash? I mean, don't have a whole lab, it's just my room have been sort of made into a big pile of storage. Equipment storage, I would say. The most most politically correct way. So basically I have a few things here. I mean, when I was testing the blower, which I have outside now, as well as the rest of the tool, I had more things in here which were more visual. Currently don't have too much things, just electronics and the, as you can see, this is kind of like a gearbox here. This is a planetary gearbox in the Go, just I don't really have time to fucking finish it, as for the soldering and all that sort of stuff. So I will change my pants and all my things so that I don't burn holes through it or some shit. If you have any questions, you can paste them into the section. I am actually looking at the chat simultaneously. At least I'm trying my best to. So, what do we have here? So I've already made the drawing of the. Where is this? I was figuring out which caps I was using, but I couldn't find which one I am. So yeah, these are the things. I think this is the MOSFET, and this is the Schottky diode, rated for two channels, 10 amps, 100 volts. This is the MOSFET, the IRLZ 44, whatever, 55 volts, 41 amps. But you cannot really utilize for the total 41 amps. You usually at max, like I think it is 50 or 60%. I think that the that you use, but it can draw quite some amperage up, or what? Yeah, like 12 volts. You can basically put like kind of significant amperage through it. Yeah. Regardless, having this board, this motor controller, I always struggle with this because if I do something, then it is out of frame. If I do, and these things are very small, have to add. Yeah. The main point of the whole thing is to do the burner things, but I will not I will not pretend if I do. I think it depends on what you want to do, because if I am correct, the H bridge can work both ways. Basically you can turn the direction, if I understand correctly. So I put myself here. So if you want to use the H bridge, I think it is rated for like both channels. That is why it is H, because you have four different things, like two directions that you can take the how do you say this, the voltage to or the current to. And the like a regular MOSFET is just I think you can make H bridges with the MOSFETs as well, so it is not that big of a deal, but it depends on what you want to use. I think you need 4 MOSFETs for the H bridge, or one big MOSFET, just like my one, but those are not really I have actually one, but I'm not going to bring it out. I can show it to you on the screen. I think not this one. We'll find this. It's this one. This L298 mod. This is H bridge. Maybe we can swap this to English if we want to. So full bridge motor driver module is H bridge, and you basically can switch between directions. That's what it can do, but it is very very inefficient. At least that's what I have found out, and yeah, that's why I made my own. As well as like these are only rated for 2 amps. If you want to, I can help you out with this, or I mean, I'm not going to. This is just a one-way MOSFET, so I have not made a H-bridge, so if you need that I will not be able to give you any drawings, but this is just one way chopper, but it works for pumps and blowers. It works for things that you don't change. If for a stepper, sure, you need the latter one, this, because or like a motor. I had one project where I was working with a gear and a potmeter as feedback, and basically it's a needle valve that basically has a motor and has a gearing into it. Had like need 6 times as much. I think it is 6. No. I think it is 3.6, 3.89, whatever. It's about 4. So need 4 gear ratio. So basically the motor turns 1 and it twists or like turns the potmeter, but the needle has to turn 4 or 5 times in that, so that it has an internal gearing. And the main point was that it needs to have both directions, so I use this for, and as well as this is the dual channel. If I remember correctly, you can see it on the two sides. Here there's a dual channel, so you have one out and another out. So I use that for, but it was not the best project I have ever made, I'm going to be honest, but I mean it was a good first starting. So to this, I wouldn't say garbage, but back to this thing. Yeah, I have these pins. Well, put the chat back here, make myself bigger. BTS, I have no clue about that, or I don't know what that is. Let me check. Oh, this is a board from Arduino. Base dual bridge. As well as like it is 5-volt logic. That's, I mean, I wouldn't like that, because I mean, I was working with the Arduino. I was working with the Arduino as well. I have the Uno somewhere around me, so it is, but I don't use it anymore because I have, so to speak, grown out of it, because it doesn't do, I mean, it does a few things, but it doesn't do them pretty well. It is easier to set up, I would have to add. The ESP32 is a lot more struggling to figuring things out and debugging things, but I would have to add, if you are patient enough and struggle for the time you figure it out, it will work better. This is the guy, the STM32, kind of like the Uno or the Arduino, but this is more professional. It is very simple in terms of coding language. Not that I know how to code, I will admit that. I usually use ChatGPT to generate my code, and I debug and iterate. So I go through it and then test, figure out what doesn't work, what does work, and correct it. But the main thing is that it knows a lot more. It has a lot more function. You have less RAM than an STM or ESP32 does, but it has a lot better functionality in terms of it doesn't run anything in the background. When you have an ESP32 or Arduino, it runs all the fucking things in the background, the Wi-Fi, all that libraries, all that bullshit. That takes up a lot of space on the RAM, as well as it takes up a lot of computing time, which makes the whole entire system more fragile and prone to freezing out, having brownouts, all this bullshit. And that's why they don't use it in the industry. They use either a PLC, which is a more expensive thing, but they are more plug and play, which is preferable if you are working in the industry. Or they use these ones, the STM32s, which are very good because, I mean, I will show you if you don't know about it. not just it has a lot of I/O and PWM, it also will show you can basically come into the it also, if it loads up, will show. I really hope I did launch it. I think I did, yeah, okay. So it is. You basically have like a separate tool for coding as well as for the configuration of pins or addressing the pins. Not just have a lot of GPIO, this is only the tip of the iceberg, but the GPIO have a lot of function to it as well, because F44, and this is even like a beginner, like a entry-level board, kind of like a mid-range board. You have all the pins here. You have the Arduino headers, basically the same as the Arduino. It basically, you could even put the Arduino into the pins if you really wanted to. And as you can see, they all have the same features, as well as it has a lot of extra features like having more UARTs and all that. You can set up PWM, have more ADCs, a lot of HCL as well. As you have two other rails of full, the outside rails, the inside rails are basically the same as the Arduino pins. These are called the Morpho pins, these outside ones. And the outside line here, this one, the outside, and the outside here is the inside are internal linked to the Arduino pins, and not all of them, but almost all of them have a few extra pins. The external ones are the free pins, are the extra pins compared to the Uno, as well as a few here. And basically have a lot more features, and you can configure each pin to what you want it to be. And you don't even need to do it in the code, you can do it here in the MX settings. Basically, if I really wanted to use the PC6, which I have no fucking clue where it is, PC6, it's in up here, I basically could enable it, PC6, I could enable it and set it. These are the functions that it can do. It can do, I have not even clue what it does, this T0, honestly. It has SCL, which is good for like thermocouples and all that. MCK, have no clue again. D6, have no clue. Timer, these are the channels, two channels for PWM. You have also UART, GPIO input, which is usually like I don't know what is a GPIO input. I don't know what a GPIO input is or what it can be used honestly now. Have a GPIO output that can be used as a real input, GPIO input, maybe maybe some digital signal reading that can be, if you, I'm not sure about that. Output I usually use as like limit switches or the thermocouples as well, use these. Have XT, which is like external interrupt, whatever event shit. It is useful for I think this is, yes, the limit switch is this actually, not the limit switch does basically, it outputs voltage continuously through the limit switch, and when the limit switch clicks, it basically breaks the circuit, and then it pulls up or pulls down to ground. So internally the voltage through that, it doesn't go to the through the back to the ground of the STM32, but actually to the through the it goes to the ground internally, not through the limit switch. That's the main point. So yeah, so infinitely more configurability, and you have a lot of more settings internally. You can set this sampling time, all that kind of stuff. So there is a lot of settings as well. as you don't only, if you are interested about GPIOs, you don't only have this Alco FP64, which means that it has 64 pins, but actually the maximum pins is 144. That is a bigger, more like called the F446RET. Pretty good, as you can see here. Yeah, for 144 pins is a huge, as well as like you can add external. There are like I don't know what do you call them. It's like add-on board that you can use to like have more I don't know ADCs or something like that. But this is very good. But I will add that it is a lot harder to get into in terms of setting up the MX and generating the code, finding all the and creating the libraries for yourself. It is a lot less beginner friendly as the Arduino family is. I would have to add. So I have been struggling heavily with that, but I will add that this is pretty good in terms of configurability. It is superior and a lot more robust as well. So now back to the work. Breaking off the little remaining plastic parts of this shit, if I could. This breaks pretty badly. I mean, all of this is for the control of the burner, which is a very multifaceted project, I would add. Needs electronics, needs blowers, pumps, all that sort of stuff. As well as I said, it needs automation, which is why I use the electronics, because technically you could do it with manual settings as well, but it would not be automated. Fuck. God damn it. Cleaning off this garbage from here. I mean, I actually have seen this, that they use these types of breadboards, these nice breadboards. I thought to myself, how could I make the whole thing more I wouldn't say robust, but better looking as well as more organized, because currently I was having these wires all over the place, very shit solder jobs in terms of like the, as you will see soon. I mean, I will show it soon. And like as you can see here, it will be basically able to like removable. It's kind of like a shield. So the point of the whole thing is that fucked it up because I supposed to solder it on the other side, but main point is having these, as you can see, I have made this very poor. I mean, at the time when I was doing this, I think 2 months ago, I mean 1 month ago, I didn't really know what I was doing in terms of like how to do it better. But I mean, you can see that we have the ground wire, and this is the 12 volts. This is the ground wire. We have the caps here in between, soldered to it. It's kind of shitty, but I mean, it was working for a time. As well as you can might be able to see here in between the legs of the cap that there is another cap, which is a far smaller cap, kind of like 3 millimeters width or something like that, which breaks off all the time. So I will have to add that as well. I mean, I have added these 100 nanofarad caps are always on the blocking board. They need to be put in there. Probably will have no focus whatsoever. This Droid cam application is not the best, but here you can see it, or I mean no, here. There is one. We have another one here, if I am correct. Yes, one here, and we have one here. Yeah. So need to figure out. We'll salvage the remainder of the components, then I mean, currently, I should put the, oh, I'm so bad, again. Forget to change the scenes. Should add some scenes into it. Yeah, I'm working on the prototype currently for the burner. I have had this, move the plug, hopefully. Oh, I can move it, can I? Yeah, I can't remove it too much. I might try to move it into the frame, or fuck it, move the camera itself. So here we have the board, the remainder of it that I have not got teared out for now. Removed a lot of things from here, and we'll add the protoboard back in here rather than there where it were. We'll be able to put everything here, and we'll be able to make the less of this, which is the jungle currently. So let's use, like, currently we have two bubbles to the what is this, the thermocouples common buses, which are the, I think this is the HCK and this is the MISO, but I'm not sure which is which. So yeah, and now I mean technically yes, I have been working on this particularly, but I'm usually not just mainly prototyping as like a hobby, but I'm building a burner. So that's the core pillar, if that makes sense. Again, I mean this will be fine. Turning on the, I will salvage the parts. Yeah, we'll I mean tested these, and they have worked better than what I have been what I had, which the problem were the MOSFETs got fried because or one got fried because we didn't have the 12 volts. This is the low side switch, they call it. Basically it does use 12 volts instead of 3.3 volts, and that way it you are out of the saturation point or zone when the resistance is the highest, and or like it decreases the resistance as you get as you increase the voltage, and that's why we use 12 volts instead of the 3.3 volts. Basically, if I use 3.3 volts, and that way the MOSFET got fried. When I use the 12 volts, the MOSFET did not got fried. So, or fried, and yeah. Right now I want to get the, maybe I will cut these. We'll try to desolder it, but if I don't succeed, then I will just use the Okay, one is done. Goodbye. Okay. Oh, hotpot. Okay. Turn the guy off. Good. One is done. Great. I can toss this back to where it were. To the wires. Remove the other one. So this is the caps, which I apparently do not know why you need, but if I remember correctly, you needed to set something up. I honestly don't know it too much. Come out. What a garbage. Okay. Fine. No, I'm not electrical at all. I basically looked out everything from ChatGPT honestly, and then iterated and made the whole thing work. Tried out a lot of things. Usually figure this shit out for myself, so to speak. I do not really. I'm not like into understanding the everything. I just want to know how the exact part works, why it works, all that. So that's the point of the whole thing. Currently, I'm gonna just make the whole thing work so that I will be able to control the burner, because the main point of the whole. Come on. I'm going to cut this off. Good for you. I mean, so currently we have the cap, and I have the drawing here, which is where is it? Not this one. I have hand drawn this shit for myself. This one. Made it. So basically this will be the wiring that we are going to use, and then I'm going to put this to the side. Now if I can make the half screen. Fuck. Whatever. I'm going to use this. Put this to the side here. Very boomer. Just want to see the chat. Oh. Is this a joke? Sorry, I'm just boomer. What is this? Good. Okay. Not the best with technology, let's be honest. So yes, this is what I want to use, and point of it is that I will need to remove the caps. I need I have a snipper or like a tweezer, whatever hole. I bought few of these because we'll get into a hot air station. I have even bought one, cheap one, right? So that I would be able to solder. I have a very small, I'll show. I have this good old boxy here. We'll make this full screen again till I don't forget it. Where is my? Okay. I mean, technically, first I will show the what do you call this thing? It's called the Texas Instruments 1004 FDC 1004. This is it. So it looks don't have any. Looks like this. It's kind of like a small IC. Main point is, where are you? Is there anything about it? It's not too bad. It's like $1.3, so it's not the price. The problem isn't the price. The problem is the size. The problem is the size, which is 3 millimeters by 4.7 millimeters. You have 10 pins. Good luck soldering them with a soldering iron. So yeah, that's the problem. And if you don't know about this, this is a FDC, a 4-channel digital or capacitance digital converter. If you don't know about it, we'll draw a bit. That's my secret sauce. I like to draw. Basically, we have a burner and we have a fuel tank for it. And I'm going to draw it this bigger. We have a fuel tank. We have fuel in it, and we want to know how much fuel we have in it, because we know that the height of the fuel will give us a rho times G times H, which is H, which is basically hydrostatic pressure, and will increase the decrease the hydrostatic pressure as the fuel line drops. That is going to influence the pump carriage, meaning how much fuel you carry with the pump. And how are you going to measure this? There are multiple choices. You can have a float, or you can have other things, but what I wanted to use is one that is called, I use red and green. What is called a capacitance based level measuring. You have two electrodes in here, which are basically like copper plates bolted onto this is basically going to be just the what do we call this, plastic that's going to be put into the house with a if you really want to be tactical, this polypropylene, so that it doesn't oxidize in the fuel. It is put through here with a cap onto it, so you can de-thread the whole thing, or like take it off. It has like a flange that has holes, so basically you can put screws through it and have a sealant around the inside of the flange, and basically that seals so it doesn't evaporate and doesn't leak out, meaning the fuel. And on the polypropylene plates, you have copper plates that are screwed to it, and the copper plates basically have leads outside which are not connected to the metal house of it. And wait a minute. Igen? So the copper plates are screwed to it, and they have leads outside. and one is connected to GND. I'm going to draw it GND, and the other is connected to 12 volts or whatever, what have you. Basically, you create a big capacitor that you will have a voltage potential between the two, and that is going to give you a capacitance. And the capacitance of this capacitor can be measured via this what is the name? Texas Instruments 1004 FDC or whatever the name is. And this converts the capacitance cap to digital signal that you can use and basically register on the STM32 or any microcontroller. You can calculate or like basically like log it and all that. But why is this good? Because as the fuel line changes, so is the dielectric in between, meaning that you have here you have air and here you have fuel. And as the level drops, the capacitance changes because the capacitance of the two will basically influence how the capacitance changes. And the more fuel you have, the higher the capacitance, because the fuel seals better than air and all that. So it is a higher dielectric, if I'm correct, but I don't know if it is lower or higher, but I assume it is higher. But it is different nonetheless. And as the level goes down, the capacitance drops or changes. And as the capacitance changes, so is the digital signal that you send out. I don't know if it is voltage related, whatever it is. And basically that means that we can sense and realize the change in height. We can basically empirically measure out what the initial top and what the bottom is, and then we will have a, I wouldn't say so linear, because we will need a cylindrical or like a cubical body or fuel tank to it. But I have a Trabant tank, which is going to show. You can use it with any liquid, but the it depends, because if it does conduct electricity, it needs a barrier. I have read it, you use Teflon or something like that. If it doesn't conduct electricity, it can be used bare metal, so you can have the electroplates in between the liquid, as well as if it doesn't corrode it, so it doesn't react with it, then you can have it. But if I am correct, though copper does and can react with fuel, it does, it can react with it. So because it catalyzes some fuel oxidation with the veggie oil that I have, so that can be a problem. But if you drain the tank or like have the accept the degradation, then it's fine. Or you can use a different metal. You can use like steel or whatever, or like coat them, whatever. Trabant tank. So this is the Trabant tank that I'm talking about. I mean, yeah. This is how it looks. I mean, mine is looking like this, but it is very useful because it can be like purpose. It is 24 liters in volume. Yeah, capacitance to digital converter. It has no moving parts, can run forever as long as the board doesn't break and the capacitance doesn't drift. But I suppose it doesn't have any like real lifespan. They use this in aircrafts, in big jets, to determine the level, because there they cannot use like floats because of the negative G or like all that kind of stuff, and it is not that precise. This is basically within, I think, 0.5% or something, very capacitance based fuel level sensor versus float. That's like kind of like the toilet has. It has an arm and it moves kind of resistance or some shit. Yeah. 0.1 or 1% ish. High durability, no moving parts, continuous level sensing. Yeah, it has that as well. The mechanicals have like lower, about 5% dead spots, as well as they have no continuous. So basically when you have some level drop, it doesn't move immediately, so it has a bit of dead time as well. These don't have any of that, as well as like is not basically resist or prone to like misread data or have any jitter if there is vibration or something like that. Maybe if the virus get loose, but that's a separate point. And yeah, so it is like very good. The one point that it doesn't have versus the float, it is that it is a bit more expensive, but that's all. They use this in the aviation industry to measure the fuel in the aircraft wings, or in the tanks, whatever, what have you. They use this because they want a precise know of how much fuel they have in the tank left. No, I don't have a business. It's just for the burner I wanna make. I wanna learn as much as possible in terms of I wanna build a maybe a consultant business later on, design parts, be a process engineer. I am attending university in that sense. I am just enrolled into the MSc, so master's degree with the process engineering, but this is more of designing the reactors and all that. This is more of a mechanical and how to, or there's like two types of knowledge. One is the called declarative, which is that how you know something that exists, is know about. The other is know how, which is procedural. This is kind of more procedural that I do. I need to figure these things out. I mean, I have known that there is this capacitance things, but the point is that these prototypes are to learn. So basically I build a burner that I will use for creating synthetic fuel later on. It will be the burner is there to create heat, so that we can use the heat to I haven't decided, but I think I will do a boiler to create process heat, which is basically necessary so that we can come on, separate you fucking process heat, so that we can basically use the heat to, sorry, I'm just concentrating here, create synthesis gas, which is there to gasify biomass or waste, take heat and create charcoal of it and gas. The gas can be used to run into Fischer-Tropsch, which is a chemical reaction that generates fuel out of gases, mainly from synthesis gas, which is a combination of CO and H2, meaning which is very useful. And there are big companies that use this. I mean, it's not a new thing. Fischer-Tropsch's name is implying that it was invented in Nazi Germany back in World War II, or I think it was before that. They didn't have fuel. The Nazis didn't have fuel, and they start to use coal as a raw byproduct, or like a raw initial product to basically make diesel and gasoline, so that it can run the tanks and all that. But yeah, the point is to have the boiler and the burner and learn as much about the whole thing as possible, because these all need electronics, control, all that kind of stuff. So we have removed one of these very little tiny fuckers. This is the cap. This is the 100 nanofarad cap. We'll put it into the crater here with this big thing. We can have him rest there, and we will take it aside and remove the other cap from here as well, or two caps to be honest. Separate them. We'll solder the little cap on the bottom of the board. We can have enough space for that. Yeah, sorry, there is like poor lights because the pen lamp is exactly where the phone is, so it's kind of in the way. Should probably put the phone there, but I wouldn't have enough cable, I think, for the charger. My phone is not the best. This phone is not the best because it is kind of like a uh-oh. I really hope it did not break off, because it usually does that. It's very annoying, pissing me off all the time. It does that. Yeah. Take off the garbage at least a bit, so that I will be able to put the guys into the holes, and I need to cut the legs off. Oh, I need to put the into the crater as well, so that it doesn't fall to the side. But yeah, I usually build like mechanical things and all this kind of stuff, and the point is that why is this? What was I saying? Yeah, I will design tools, or like not tools, the systems, like let's say there is one system that is called I mean, it is not really called anything. It is just an ammonia process, basically creating ammonia from urea, or like carbamide, which is all blue, and all that kind of stuff. It's kind of interesting. Not even the reaction itself, but the process of automation, of how you can scale things up. That is the more interesting part of the whole equation. So I will put these two. Okay. Need to go for a bit of break, so grab a tea or coffee or some shit. In the meantime, I will do as well. So yeah, the point is that we have the other board, this one. I really hope it is wide enough so that we can put it on the two sides here of the middle. I really hope. Oh, great, lovely. So basically we'll have it here, and then we will solder it in, and we'll have to figure out which pin is which? Where is the... So that is the right top corner. That is the hole. And there is like a little dot, like a little hole on it. It's going to be the right top one. Yes. Right top corner. So it's going to be the 5. That's the right top corner. Okay. Right top corner. I will make myself be bigger in the meantime, so that right top corner will, I mean, it's actually the other way around. Yeah, it's here, so it is mirrored. So the 5 is here and the 8 is here. I need to mirror it. Oh fuck. Yeah. That happens when you flip the whole thing. Okay, at least we now know that we have it in the right corner, right top corner. That is where the thing goes. Yes, right top corner. Double, triple, fucking quadruple checking it, because I usually, I don't know, ADHD or some shit, usually switch up the wires, even if I know which one should be which. So how are we going to make this? I think I will solder the guy in and then add the, what do we need for this? We need the power and the ground to I mean, I'm just thinking because I'll put this to the side here. Oh, here we have a bit of leftover. Good to know. I have not wasted all of the stuff. So have these leftover pins, if I can get them out. Thank you. These ones, these males. These are what we are after. Put the rest into here. So yeah, these one for them. Yeah, I will need two, because I need to break this as well. And I can break this with hand. Yeah. So we need two for the yes, one for the ground, or we need one, because we need one for the ground, but we need to jumper it anyways. Yeah, we need the 12 volt to connect there. Or do we need to connect it here? I'm not sure. No, there's a thing called ground loops, meaning that you create too much ground connections and create like loops, which is not too useful, can cause some problems. Can't remember what, but the ground loops are not too good, so you don't want to like create too much ground to ground connections. You want to have preferably one star ground, which basically is like a hub, and you have all the grounds going out from all the parts. You have it connected to one, and then it goes to the power supply. But I think we can have that we have two pins for the we'll make it half screen. We don't need the whole screen for now. always scale the other one so we can have it half screen. We'll put it maybe here, so we have it here. How much is this? Where's this side? In the middle. So basically we have the whole thing flipped, so here's the whole and we have the whole thing mirrored, but doesn't matter. The point is that we need to have the ground, which is the 5, but currently I think it is flipped up, so it is not called 5. This is the 8 on the board, whatever. So this and the other wire, which is ground, should be so this is, if I remember correctly, yes, this is the PID in, PMW in, PMW in. This is ground as well, or this is power, ground. Yes, so PID comes here, PID PWM. So yes, how much pin? We need one jumper from here to here, and the other wire will come in here. I think that's the two was the, yeah. So we have a jumper here, top, right top. So basically we would have need to have a jumper, and I use this 22 gauge little black wire, and I mean, maybe I will zoom out. So basically we need to take this apart. Now how is this? Yeah, feel free to fucking wind down Tom completely, thank you. So we'll need a ground from the second pin to here, but we need also a, do we need? No, we don't. So we can do this. The other side is a bit more complicated because we will need to have capacitors. So we need the 2 caps. Yes. So we need the ground in, power there. We need a cap between them. Oh, that's going to be a bit hard. And we will put the caps between here. Okay, that's fine. So we will come with the yeah, jump the ground in, jump the ground to there. We have the 2 caps here, so 1 cap there, 1 cap there. Have the power pin there, have the ground pin, I suppose, there next to it, or maybe on the other side. Need to think about that, but probably next to it is fine. We need actually a 3 long one, not a 2 long one. The 2 long one can be, we'll break down one. We'll need the power, the ground, and the PWM. And the other one is going to be ground, but that's going to jump from here. I'm just thinking out loud. So yeah, gonna take my break now and gonna come back. So make sure you grab a drink or something in the meanwhile. I think it's about 10 minutes. I mean, I hope so. We'll see. No problem. We'll open my window here then, so that we have some oxygen. So I usually suffocate here. Not literally, but like I usually run my mouth a lot and ran out of oxygen quite soon. Hooray! So pancake, hey. G and D. When was this? But now we can make the thing bigger. Yes. So what do? We need the pins. Need to have the PWM out from there, which we will use as a pin. The other is ground. We need a single pin and I'll break one of these up. We don't need all of these. I can't break it up with one. Fine then. Fine. At least these are easier to break up, a lot easier than the goddamn females. And those probably are not supposed to be broken up. So how long should we have? What is this feeding? We have the ground, which, let's say this is the thing. We need to have this long, but we have, probably like so. Do not need too big of a wire. I will give it a bit more meat. Let's say this. It's hard to put these little shit wires into the blanker. Falls in. Come on. Maybe I should buy a fucking. I mean, technically, I do think we do have the. There is like one little, kind of like a plier that you put the wire into, and you basically pull the thing off. But I suppose. This is going to be a bit short. How short is it? I think the second one is the what we need. No, it's good enough, except the board is going down. Yes, we can now solder. Hopefully this way it will not fall out. Good. Great. Yes, sir. Yes, sir. We are building, assembling. A bit dark in terms of color, not in mood. I wish I had a better camera. I wish I had a better camera, honestly. I would happily use it. There is no focus whatsoever. -1. Solder. Nothing. Hope this shit works, cause it works. Okay, just heating up, cause they die pretty soon. They're kind of shitty soldering irons. Need to buy a better one. I do have a stronger one, but there is a lot heavier. Okay. Although I have a better idea how to do it, so I will. What I will do is that I will cut down the wires to length, and then going to cut down the wires to length, and then I'm going to solder everything at once so that we don't heat the guy up too much. So what we need to do is we need to flip the switch, or so to speak. We need the power to be on this side, closer to the motor controller. We need to be the power, that's ground. Yes, power. I mean, technically we don't need. We can use one for the power, and the other wire is also connected. So we or is it? Yeah, I think we need it to the yeah, we will use two, whatever. We will use two, so this is going to be put here. So yeah, we'll need the power and the ground, and then 12 is going to be the PWM, so we need a 3 long pin, actually not a 2 one, as well as we need one PWM out there, and we need a ground connector there, a jumper, whatever. Going to cut a 3 long, have a few pins here. If I get it out. Struggling. So we have this 3 long pin. one, we need another one, and put the rest here. Very useful kit nonetheless. So the 3 line should be put here, and we will use a jumper between the ground and the, yeah, we can jump the ground here, so we need to cut 1 wire from here to here, probably like, I mean, probably this big. I don't know if I could blank it with pure hand. Can't really, isn't worth the trial to break the wire. Of course it's not in the frame, so I'm actually blanking the wire. Bending it. Probably will be fine. Minus is the top pin. Good. Okay. Bit taller, but going to work. So yeah, that's one ground, and we will need to jump the ground between the two, so we have a common ground. Yes. Need a common ground, and then I'm going to blanket on the wire here. Not need too big of a jumpy. I think we are going to cut it somewhere along here. Come on. Bruh. It's a joke, ain't it? Fuck. Probably not the best way to do it, but I will take it. Need to bend the guy. I don't know how far this needs to go. Still not okay. Alright, now better. So is power, right? Power, which is, yeah, power, ground. The third one from the left should be the, which is this. So power, ground, power, ground, PWM, power, ground, PWM, and ground again. Great. And we will need to put the caps there between the two fuckers. So we'll need to cut the watt wires. We need to, I don't think I need any. If the PWM signal comes in, you have the one for the PWM out, and I think we will need to put the caps in. I need to cut them. So that I put the guy in. This is ceramic, so it doesn't really matter which side it is on. Have no space from this shit. On the right size, of course. Yes. And then we will put the other on there, under it. Good. We would need to bend the wires from the bottom so that they are kinda, I don't know, which one is this? Bending the wires a bit so that they do not fall out, hopefully, or at least not that much. They will wiggle, but they won't fall out. At least that's what I'm hoping. Yeah, they will not fall out. Not that much. Good. And I don't know if this is whatever. Pretty. Oh, this has been already soldered. Okay. Not going to bother with it. I have to solder these in nonetheless. Oopsie doopsie. So I will solder this at the last. Okay, fine. Fine. So, how do we do this? We take it. First turn on the guy. It's not an easy thing to do. I mean, meaning the STM32, it's a difficult platform to get into, so get ready to that. Like expect hardness. It will be difficult. Teensy 4.1, I don't know what that is, but we'll check. Oh, it's kind of like a Raspberry. Okay. luck with the STM32. It's tough to start, I would say. I will also add that I'm not even doing the coding, and I struggle a lot. So yeah, that needs to be kept in mind. Okay. What are you doing with the TZ or whatever the board is called? What do you do in terms of projects? Oh, you the bitch. Adam, are you still here? No answer. Unlucky. So we have added this. We'll now add the other thing, which is the technically need to do the same thing twice, so it should not be that difficult. So yes, hopefully I will not fuck it up, but yeah, I will make this work. Random ass wrong legs. Come on. Cut the wires, right? That's for now. Yes, we need a short jumper. So oh. So yeah. Adam, are you still here? Unlucky. Whatever. So, continuing the work, I suppose. Probably this is a bit too tight. Yeah. So ground to this ground. Too much things here. So, mm-hmm. Alright. Okay, we have this as well. We'll need the bottom jumpy, and then we are going to be Gucci. So, the bottom. Yeah, I bought these 3 spools. Pretty, I wouldn't say expensive, but they cost a lot compared to they were just, you know, wire. Probably the 3-pack cost like 100 bucks. I mean, even more. Yeah, because it was not cheap. I mean, at my, you know, shit currency that I have here. Kind of expensive. So 100 bucks is a lot for just only wires. But I suppose it is 300 feet after all, which is 30 meters per spool. 30.5 to be tactical. This probably got to be a bit too long. Oopsie oopsie. So we have it here in the second. So hole, right side of the hole. Here. It doesn't look too nice, but I suppose we'll do it. Alright. Everybody is nice and steady. We now need to things. We need to put the 100 NF caps on it, and then we will add the 3-piece connectors. So let's go. Okay. Oopsie. Right. I'm okay with that. I'm okay with that. Alright, so good. Good. Caps and big things. Alright, let's do this, shall we? Let's do the, what do we call this, the soldering. Then I'm going to put the pins in as well. It's going to be lovely. So, the board is shaping up, or taking shape. Yeah. solder. Alright. Yes, so here is this. So continuing deep soldering. I'm gonna put on the 100 nanofarad caps in a minute. Alright, need the batteries in. Very little tiny shit. Wait. Hope I did not burn it out or some shit. So we'll be putting in here. I need a bit of stuff. I wish I had was not shaky. Hand is shaky. I'm not going to go to. Not going to be a surgeon. the solder under it. Need the second thing, which I think is this. Yes. Sound of misery. It has fallen down. And where? Oh my fucking god. Oh. Found him. Hallelujah. Almost. Please don't drop it. Whew. Whew. Fuck. Danger. Feel like danger. A bit of solder. No, it's not hot anymore. Fuck's sake. Yeah. No, what happened? It's going to be fine. Hope it will be. Okay. So what we need, the 3 pins, so we will need to put them here. And there. us up. Masonry is here, doing some soldering. Hooray! So, we are going to be zooming in a bit, if I can, not this much. Alright, we will be adding the other three. So basically creating the protoboard for the burner controller. It is not the whole burner controller, but most of it. So, or not most of it, but the chopper, meaning the fuel and air blower. Good. Oopsie. So let us do the rest. Can't. Oh. Ah, god damn it. Alright, I think we are done. The last pin is just not the best jobs I have ever done in terms of visual quality, but I would say they will do. it is. Lovely. Yeah. I need to solder this in the right direction, so like so. But not there, to here. Yeah. Yep. Having the soldering iron. Great job soldering the fucker in. Alright, fine. Now we need to put together the other board and the other thing. This will do. Put it on here. I need to break a bit of this. if I flip it, so now it is in the left top corner, just as it was, and now it will turn this side and put it to the right top corner, which is this side. Yes. Oh, the board is a bit off. Understand it. So, yeah. Powering on. Hello. Stringer is here, soldering the control board, this protoboard here together, so that I will be able to use it later on, controlling the motors and all that kind of stuff, which will be a part of the burner complex a system that we can use, meaning this, that we can use to generate steam and to a boiler. Basically that's the job of the burner, or create heat so that we can create biochar and gas, so that we can run the gas and produce synth fuel from it. Shaky hands, but got the job now done. So what up? I'm looking at the comments, so you can ask any questions, or yeah, feel free. What the fuck? So looking pretty lovely. Maybe solder this a bit over. Bit of garbage. So yeah. So the board is done, and hope now we will have the test, which will be the ultimate test, which will do a continuity on the wires. Going to test each of them, so to see if there is any shortage, or like how the things are going, all that kind of stuff. And yeah, so So we have the ground here, and we have it. Okay, so we have the G and D. Okay, okay, we have it here as well. Okay, we don't have it here on the 12-volt side. We have it here. We have it here. Don't have it here anywhere. We have it here. Okay. Yeah, this is the ground side. This is it. Okay. Good. Good. 12 volts. I mean, it's supposed to work. Maybe. Oh my god. I mistakenly made the problem. Yes, I have switched up the grounds. Yes, exactly. Because if the right is the left or the left is the right, then we should jump here, and this is here, this is here. So the second, which should be the ground, should not be here, nor here, but actually here and here. And these will be the PWM outs. Oh fuck! I fuck those. God damn it! At least I have realized in time. So removing them, great, very well. I mean, technically I only need to remove one of them. Yeah, these inside pins, because then the outside can be like this. Oh fuck. Yeah. I think I will go and have my banana tour mix. Then I'm going to come back after I finish this or do this. So yeah. Tock, tick, tock, tick, tock. I don't need this. Buckingham. Igen?
Fú, itt nagyon hideg van, boton, mit csinál?
So I am here, actually just my mother came up, and I'll bring it out to the sunshine. So we will have not too much sun here. Is this better? Technically. So we have the motor controller and the two lower side chopper, MOSFET controller, whatever things. So there, everything. Now we'll be able to test it. And oh, forgot, we need two pins, two single pins put here and here. Just need to solder them in, cause the need to wait till the soldering iron heats. So yeah, not the most interesting thing I would say, but this is what we have. This is what we have to do in order to create the thing, or like make it work. Yeah. Regardless, we will do it. And currently, one is done. Gotcha, bitch. Anyway. So what up? How was your day? So yeah, I mean literally. Is this still on? No. Not the best looking paint. And there is no focus. You can't see jack shit, unfortunately. So here's the board, and yeah, I did these, not these two. These are going to be the PWM outs to the chopper board commercial. So here we guy, and I don't know. Here's the chopper. Here we will need this board to be able to power, or like sort of power. To break this shit off, and we can put him here. There's plenty of room, and probably thinking how to do this, cause need to have one of this here, one of the other thing is going to be here. So these two are the PWM mounts, meaning that they are powering the chopper board, which are these two. Chopper board is the whole thing. They control the blower and the motor, or yeah, I suppose the blower is the more chubby, robust one. And we have the PWM in, which is, I mean, we can replace this to a regular wire probably. I don't know why I made this. Regardless, we need to hook this up. Also, I might need to be a bit jumpy, kind of skitsy, fucking ADHD right now, in the sense that this is kind of far away, so if we even put this here, garbage shit fucking broke off. God damn it. Take the whole board, put it somewhere here. Even if from then we need to take the, or we need to add the chiller. Alright, fine. We're going to be okay. Not gonna die. So we can put three, what do we call this? Like a line here as well, doesn't matter. As well as we can add a few pins there, doesn't matter. So that we can jump the 5 volts all the way. Alright, so we will need to remove this and add more pins to this board. We need these lovely male headers, because the male headers, we'll need to use a lot of male headers so that we can basically use these simultaneously, meaning the 5 volts devices, this and this, which is the you cannot see probably, the Max 6675, which is a thermocouple, and this relay board. These two operate from 5 volts, so they need both 5 volts, and need to divide that, as well as this guy needs 3.3 volts, as well as these guys need 3.3 volts, but we have a 3.3 volts there. I'm going to label it, which board is the 3.3 volts. Oh, you back at them. Alright. At the top, these two, the green ones, yeah, they are so-called boost bars. They basically are there so that we do have the blower, kind of like this. It is a car HVAC motor, can draw up like 120 amps. That's, or 120 watts. Sorry, not the same. So 120 watts. That's at 12 volts. That's a 10 amps. 10 amps. 10 amps of power, and that's a lot. And that's going to melt through like Vagos, all that kind of shit. These Vagos are only rated for 20 amps, but they don't fit the bigger, thicker wires, unfortunately. These, not these ones, because I think 10 amps is ooh, I don't know which one are they rated for, but from this we can run a lot of things. I have calculated it, and these are like 1 centimeter, so 10 millimeters thick copper sheet. I don't have the sheet material here because I used it up as a washer for the burner, but this is 1 millimeter thick as a plate. It can have about 150 amps of current passing through it. So yeah. I don't know. I will need to add a few more. Be patient, be patient. I need to add pins, these mail headers onto it, because I have realized that I need to put them here and here, not here, because I might will remove it from here, though I don't know if I can. I might be able to if I use it. I have some desoldering wire. No, I don't have fuse in the terminal block, but they are here in the chopper blocks. You can see them. They are car fuses. Both of them are 10 amps. So if you drew a lot of amperage here, then they are going to switch the whole thing off. The 12 volt only is what it was. The 12 volt is only coming in with like a lot of amperage to the boards. The chopper or the low side switches are basically nothing. Like, I think, I don't want to say bullshit, but I think it's less than 0.1 amps running through them. Yeah, nothing really is going through there. I mean, that is only power from 12 volts. Yeah, the others are all 5 volts or 3.3 volts. I mean, I don't know. It has worked, so I will not say that it is a good design yet. I need to run it for a long time, but it is still better than the previous one, because, you know, as I said about the what do I call it, the linear range, or the the saturation range was low with the 3.3 volts from the STM32, and that's why at low PWM the chopper basically got fried to death. And yeah, we need to remove this little block here. Maybe I will add them there, doesn't really matter. We need to add 3 here, 3 there, 3 there, so that we would have a lot of terminals that I can use to jump around to the devices. And then the problem is that I do not have neither the blower neither the pump here. I will need to bring the blower in so that I will be able to see, and I will be able to do it with both of the channels. The PWMs are here and here. These are the outputs of the wires. We'll guide them there, towards there, and yeah, I will flip the whole thing so that we have the STM looking my way. And yeah, I will need to wire the whole thing up. moving there. So I will take a little break. No. I will use a steel box. 3D printed parts are not good around the burner, which is hot. I mean, because now it is not insulated, but you don't want it to be made out of plastic. I am not trusting even the. There are the ASA, so ASAA. That is the material that the professional board or the professional. I think this is made out of that. I'm not pretty sure, but I think so. These boxes, these plastic ones, are made out of that. This inner thing that I have added, this is Bakelite. This is basically the same thing as the chopper sits on. I have made I was broke as fuck, and technically I could have bought one of these, but if I am correct, they only are rated up to like 3 amps per channel per line, so they are not useful because these can run up to like 7 amps of current through them. I think the lowest or the least how do you say this, the lowest point of breaking is the wire that I use, which is this 1.5 millimeters thick. I don't know what the cross section is, probably like, we'll have to measure, but I use something like this on the underside of it. Basically you cannot see because the whole thing here and here, it is connected on the underside with the wires, kind of like this. I didn't know about these things back in the day when I was making that. So yeah, for the board I would use kind of like a I think not this one. It looks kind of like this, or let me see, 200x by 300x by let's say 200 by 200 by 200. Fuck off. You have seen that. Oh god damn it. These are not the right ones. There are these professional like no, not this is not the name. It's a this is it. Fuck you. These are them. This is it. IPP6. This is it. I wanna buy one of these. It's kind of like $100, but I think I can get one of these cheaper. And you can see that these are like, this is like a PLC boxy. You can see the wire. You can see the sum of the connectors here. Yeah. This would be no. I don't study these at college. I'm just I have seen a lot of stuff, let's say that way, and I'm figuring these things out. As I said, I would say I made the chopper in November. The chopper board was made in November. I think I added the boost bars at November the 1st or the 1st of November, whatever, and yeah, so I mean, back then I didn't know these things existed, these solderable protoboards, but I have found these, and you know, I was told, I mean, I usually find things out as I go, and I usually, I mean, I would if I could, not in the I don't know, maybe I could, but it would take up too much energy to, you know, figure things out, get the paths, all that. I don't know. So yeah. For now, we'll continue with this. So again, I think I will go to a break. So sorry for that. But with renowned or I don't know, renewed whatever energy, I will come back and do some more soldering. I mean, as I will get more into this, and I will get I mean, maybe I will buy myself a new camera if I will have some more money or whatever. Just this is one phone here. Unfortunately, it doesn't have a good ass camera resolution. It would be so much better looking if it had focus. Yeah, no, I don't. I work on this alone. I was learning in college or like university, but all the others were like, I mean, I went to university to study vehicle engineering, which is not this. Not, I mean, yeah, this is not it. I would say this is closer to energetics or like um, what do we call this? Process engineering, I would say, and I'm actually studying process engineering currently. The I mean, this is kind of with like you need to solder, make all this stuff, kind of. I mean, necessary because I would otherwise need to have like a technician or somebody who makes all these. But probably nobody is. I wouldn't say in my country knows this, but I think very few people could actually think like put this together. In terms of probably I wouldn't even know them. I mean, electricians, yeah, sure, they would make a protoboard or something like that. But it's about like learning the things and like putting the pieces together one by one, because first it was just the not even this, it was the Uno, then it was the STM32, then I used like these little thermocouples, and then I used like with relays as well. First it was the relays, thermocouples, then pressure sensor, then got to do the chopper with them as well. Probably the chopper was first, and pressure sensor probably a pretty good new one. The other were I bought and were pretty useless. Couldn't use them because they were too big of a range, 200 kilopascals, 2 bars gauge. So yeah, a pretty big leap from when I started. Had fucking zero knowledge in electronics. I bought my first Arduino. I think it was like 2 years ago. I want to say now. Yeah. Since then, I have did a lot of work. Learned a lot. Probably in the last half year, I would learn the most. Basically, because the Arduino didn't really teach me that much. This STM32. I mean, I didn't have to technically, to be honest. I didn't start the burner project since I think last August. Last August, I would say, when I started it. Around September-ish, yeah, August. And since then, I mean, I wanted to learn about what do we call this, planes, in terms of I like the engineering side of planes, like not because there is 2 parts of planes. I mean, we can hop on. I mean, there is 2 parts of planes or aircrafts that are the more of like flight mechanics, which is about how you stabilize the plane, because you need to have it in you need to have it balanced in the air, so you need to fix the that there is like how do you maneuver, you need like forces to balance them out, or like have twists and basically roll, pitch, all that kind of stuff, as well as be stable, meaning that you have a constant mass, a point of mass and or center of mass that the vehicle moves around, and you need to position that as well, because it can be tipped when you are using the fuel or like burning the fuel from the wings or the tanks. You pump out the fuel into the not turbines, the jets, and when you empty the tanks, if the tanks are different in size, then they can like introduce some mass imbalances, which causes the mass point to wander as where the plane is like heavier, and that can cause the whole plane to be imbalanced, meaning that you will not be able to control it, meaning that it wants to jump, like give the nose up, and then it will basically like and then the aerodynamic forces will basically take the plane apart. Yeah, all that kind of stuff. But short story long, or long story short, that I like the planes, just not the stuff that I thought of. I was always more into chemistry, and not in terms of like chemistry, hard chemistry, like doing like experiments. I mean, rather that as well, but more that I would do like the processes and like kind of like distillation and all that, like oil making. Used to distill brandy, all that. So yeah, we'll go to take a break. Yeah, bring myself some tea because my throat is dry as fuck. If you excuse me, going to come back in 10 minutes, and yeah, we'll come back. I'm a bit back. So 10 minutes, I'd say. Megüttem azt, de kell legyen szerintem, kell néha működik. Egyeztetek, próbáltak? De kell nem? Csak valószínűleg van benne alapból. Mert rá van írva, hogy kell lakosság. 26 pedig kell programosan alatt. Az volt ráírva, hogy benne a publikát. És jó voltam az? Jó az, csak hiányzik róla egy felső szivacs. Ami megakadályozza a beható. Van, van ott. Ez nem jó, ez nem szivacs. Tömör, de nem megy át a levegő. Meg az a lényeg, hogy a levegő át tudjon menni. Ne hiszed oda, hogy napod nem, lehez, akkor nem a lehez, kimenjen a pára. Sorogda, homlokod lenézettem a szemedre? A pára. De ott oldál kifli. Ott vannak lupak. Vettem egy olyan maszkot, ami teljesen pofájától érzem, mert ebben meg nincs benne az alsó szűr. A képen rajta van egy alsó filter. Hogy ráakasztod két lapra. Van itt van egy itt ez. Kirakta meg. Úgy lehet már rá. Igen. Jövök, kezdem mosni? Gyorsan? Nézd meg a büdítseim gyorsan, tudja, hogy látszik. Sebastian menti főrica. almost back. Yeah. Go to the toilet quick and so I am back. Alright. Oopsie doopsie. So, what do we have? Solder. So put the camera around. Continue. Let's continue our work, shall we? So, brought myself a bit of tea. Hope I did not fuck anything up. So yeah, Adam, are you still here? Hello. Adam. Ay. He's not here. Well, regardless, we will have to continue. Fuck it. Going to use this. The 5 volt needs to be. Oh, I have a left pin. Very good. Lovely. We will put the 5 volts in here. This will be a very good experience. Although I could take this long shit and put it here as well. Cause why not? We have plenty of pins. Plenty of friends. We'll heat this up and then put the whole thing in there. Lower the guy in. So, Adam, are you here? Nope. Adam is not here. Well, lucky. Damn it. actually. Again, bad cameraman. My cameraman is not the best, I would say. So I am trying to put these pins into the hole. Only limiting thing is that this pin is ay ay. Ah, fuck. Angry. Come on, fuck's sake, go into the fucking pin. Go into the hole. Thank fucking God. Oh. Annoying ass piece of shit this is. Whew. Fine. Here, turn this off, please. Fucking hell. Hooray. Okay. We'll require another few pins that I can steal the ground from. Or should we wait a minute. So if we have this there, we can use the other rail. I'm not going to use the 2-ups. Going to wait a bit. Going to break more of these male ones. So male ones. Oh, infinitely rich from these meal ones, infinite amount, have 10 pieces of this. It's 400 pins. God damn it. Infinite amount. Yeah, a lot. Also, I wanted to jump. We'll break this 4. We'll put the 4 here. Will be the pair of these. We'll need a 4 there as well. Where the soldering starts to get serious. We'll put a few pins in there just to make sure we do not need to have more. Hope this will be enough for now. Also wanna replace the SCK and CS pins, which I would need to use yellow, but can use yellow. Yes. Exactly. So yellow. Great. So yes, we need to make the yellow jumpers as well. So we need 1 meal, I think. 1 meal. So think it through. So we can have it. Think here. Let's make it here. So we have 1, 2, and 1, 2, 3. What do we need? We need a in pin, which is going to go here. We need a maybe we should do this like so. Interesting question. Regardless, have 3. So we have an input for the thing, and then we jump there, and we have outputs. So basically, we would need 1 single one, and how is it done? So we have 1 single one, right? So we take 1 single one, we put it in, take the thing, this goes to the board. Then from there on, we take the jumper, and we have 1 here, and 1 here, and then the rest is, or how is it? Actually, we have it here, we jump from there to there, from there to there. Yes, jump there. We need 2 cables, very small. Yeah, very small cables. See this long. So 2 cables. Maybe even shorter would have been a better solution. Well, we are going to take this to where are we? This is, yeah. Okay. Bending the pins a bit. Found this helps. At least not to let it fall out whilst I'm doing this other work. So hooray. Pretty good. We'll twist them a bit to the side. I mean, we can push them to the side a bit later. So we have 3, 3 and 4, which is 10. 10 pins. Possibility for 10 pins. I think that's a pretty good deal. So we need the same thing. I think it was about this length. So we need 2 yellow wires, and then we are going to have enough of these so that I will be able to fucking foil. Yellow jumpers are hopefully not needed anymore. We'll use these as well. Oh, Musgoons. So we have the same arrangement, so we have the one here and we have these two here. This is one and the other one will be the next. Great, and now we'll fine. Hooray. So it is done. We need to add the one single falling out. Oh, you fuckers. You little fuckers. Okay, I need a single one. So I have a single one here, but I need another one. I'll break it off. Okay, and we can use the rest as the rest. So P. Oh, fuck. Nothing is too visible. I've added these four little shits. Yes, I need to add these as well. Yeah, solder. Also need to break the things. So need I have 2 4 actually. So 2 4, 1 4, another 4, and 2 4 threes. So 1 3, another 3. This got to be a 2. I fucked it up. Well, I'll put it to the side. 1 3, 2 3, 3 3, and 4. Okay, which are going to be the signals. So what are we Where are we? Am I the only one watching? Yes, I suppose. He's not in a hurry. See? Oh, I did not reply. Unlucky. Bad behavior from my part. Oh, hello. Are you still here? Yeah. So yeah, I'm here. I didn't reply. Sorry. So yeah. What up? Stringer doing some soldering work. Yeah. Adam was here, but he's leaving and coming back from time to time to look at where I'm at. Nothing fancy is happening. I'm soldering the board. If you have any questions, feel free to ask. I am happy to answer. Might not answer immediately. What? What did you tell? As well as like, yeah, sure, this is not going to get me money. I'm not doing it for that. I'm just streaming because I can. I will work. Have worked before. Then not streaming, so. Just recording my progress. Oh, for fuck's sake. Where are you? So here they are. Okay. How much? Need to add this here. If I could. Fucking hell. For fuck's sake, I have... Oh my god, not again. Fuck. Yeah, fuck you, honestly, fuck you. Not this fucking shit again. Okay, fuck. Moet ik er snel aan. Fuck. Fuck. Not again. fuck this up big time. Fucking liars. This is a fucking joke. this solder or is this the leg? This is the leg. Come on. Oh, should turn this shit off ASAP. Oh, here we have a few leftover pins that need be soldering. Fuck me! Bitch. You can't make this shit up. Fucking hell. don't fuck with that pin, alright? Okay. Maybe the two leftover pins, which is this. Alright, and we'll put the other one back to this side. Oh, back is breaking off. enough. My back is alright. Alright. Then how is this going to be? So technically we can make it because the HCK and the thing is can come from here. I mean, if they were here, then that would be a bit more work, though they would need to come across next to those wires. Yeah, plus 5 volts, plus 3.3 volts. Okay. Hooray. Hooray, hooray, hooray. So, okay. Yeah. I will be able to start to set up the thing and then organize a bit and then yeah. All right. All right. Alright, so yeah, here is the board, and what I will do is that I will get myself to it. Fuck, I need to progress. It takes forever. I mean, it's the normal C. Yeah, whatever. So this and this wire shall should remove this. Can you fucking come out? This wire got pretty fucked, honestly. I need to put it under it, maybe here. Because if this twist this, yes, you should want this to twist that way. You see. So we might need to have a shorter wire than this. In fact, I don't know, do I have any crimp kits here? This is the, that's not good. Would need some kind of forky things. Yeah, a few of these forky ones. I don't know if I want to put them on today. I don't know. Should we use the forky ones? Should we not use the forky ones? Anyway. I mean, it has at least a good connection, but fuck it, I'm going to crimp it, just going to tuck it under, fuck the whole thing. So we basically can, oh no, we can't remove that, but we will need to use this to the, we need to use this, we will put it, we will need this shorter, for fuck's sake. To check for what is what. VMod big cap. Oh, it's actually here, so this should. Fuck. Aye. Should I put this here? This would need to come because this is the driver. This would need to come here, let's say, or maybe this should come to here. Maybe I could use a smaller one, a smaller jumper, kind of like this. This is bad. This is not it. No. Fuck the whole thing. Use this long shit, regardless. Where are the PMW? So ground and this can be tied together, or can they? This is the, yeah, this is the, this is this ground. So this goes to here. This goes to the first one, to remote. Fuck off. This goes to the second one, to the ground. Can I see what I'm doing? Yes or no? Fuck no. Can't see jack shit. Okay, fine. So we have, we'll leave this. PWM signal, which will go to here. I think I'll put this shit here. Need this little fucker. Is that you, Adam? So Messenger is here and continuing the build. Now I have finished the making of the fucking tip of them. Finished the making of the protoboard, so to speak, for now. I did a lot of fucking stuff to it, and now I will wire it and put it together, and we will have fun, or at least more fun than soldering it. I mean, that was kind of fun as well. So I'm going to make myself a bit of room here, push this shit aside, make a bit of caveat till the hot glue gun heats up. Yeah. Alright. Got a bunch of fucking wires here. So coming closer. Cup of trash. Waiting for the hot glue. Still nothing. So yeah, almost at the point of where I can connect everybody up. Maybe I should not. Maybe I should not. We'll test it and can be sure only if I test it. So we have 5 watts and these two are not connected. Good. What about on the other side? Okay, ground to ground is good. Fine. We do not have the... Yeah, great. So hot glue should be coming out by now. Oh yeah. It is fine. We'll glue this here. Probably around here. Okay, fine. Got this sticky shit. Going to stick this garbage into it. Hopefully it will stick, and then we'll continue. We'll continue our work. Yes. 5 volts. 5, 5, 5, 5, 5, 5, 5. It will do. So remove the plug, and now we will start hooking this bitch up. Aye aye. So where do we start? We should reorganize the whole thing a bit. So we have the two PWMs. Alright, fine. So we need, what do we need? We need the PWM in. Oh, I should know which pin is which. So this is the plus, this is the minus. Suppose this is the PWM. 12 watts needed here. We don't need the yeah, this is the G and D. This is the power. Where did I put it? Oh, here they are. So we have the ground, the power, as well as the, what is this? Well, power. We need to use a heat shrink. This matter, because the heat shrink yellow is, and we have some yellow here, leftover yellows, though I am not sure if this is enough in terms of length, as well as like, does it go over the pin? Actually it does go over the pin, though it is a bit loose, but I will give it a bit of care. Give it a bit of care. Give it a bit of care so that it does. Alright, put the heat shrink on it. Is this visible? Actually it's okay. This will be the G and D. Maybe I should fucking solder these ends so that it is like, whatever. So we will have only this one, as well as the other one, which is, oh goddammit, this is the power, this is the power as well. Where is the other ground? Is this it? Maybe, maybe not. No, this is not it. Is this here? No, I certainly do not see the ground. The ground. We have one, oh, we have a plus. This is the two. Oh, I see. Okay. Okay. So, yes, this should be removed and we should add this. Fuck. What is this used again? For, I mean. What a great thing. put this here. Let's put this on the other fucking side if I could. Apparently I can't. This is a fucking joke, isn't it? Like, not too better, not too much better, I would say. Half of the fucking wire is out. Oh my god, like, come on, for fuck's sake. Or oh, that is the VMOT. That's the motors bullshit. Okay, and I have not said a word, so we remove this yellow shit. Then we should see another one of this. Fucking idiot. Fucking. Okay, fuck you. Gar fucking bitch. Finally. Fucking sick. Orange wire. What is the other one? I have three wires. So we have the power, the ground, the other ground, and we have a power wire. Can't seem to see here in the pile of wires. I did not put it here. Did not put it here either. It did not fall down either. So where the fuck is the wire? Might be in under my nose. This is I can't see. Would I use this? And technically, yes. No. Ah, here is. But this is not the fucking ground. This is not the fucking ground. These are not ground. No ground. No ground. No ground. No ground. No, 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 no. Where is it then? This is ground. This is ground as well. Should we use this as the power? This is not power. We can use this as the power. Put this aside, don't care. So yeah, use this as ground. And use this as ground. Is this too long? Yeah, might be. We need shorter wires. Don't have the like. What is this? I think this is the pump. Which is which? Who is who? That's the good question. So I think the PA7 is the bottom one, but which is which? Because I have no fucking clue. I might be switching it up. Probably should not do this. Remove these. Put them to the side. So this and these are signal wires. We do not care about them. What we do care about is to make this and these wires. Fucking hell. Why is this so fucking hard? I mean, I understand why they use these fucking fork type terminal connections. I will fucking change them. Round. Good. Okay. Here's the bit. Put this under. I don't think I need longer wire. I'm going to test them around. I don't give a shit. What a great fucking deal. Is this like a fucking... Sucking cock. As always. Why would I not? Yeah, that would be the good question. Why would I not? Why would I do not? Sucking the good old cock. The good old coke. I suppose we will be the power. We will be the power here. I probably should have swapped it up. This will be the shorter one. Come in here. Come in here. With the ground, which is longer. This goes there. To this pin. I have to put some shit onto this ugly ass fucking pin. Where are you? Maybe I should have put it down a bit more towards the end. Tight, tight, tight. Oh great, what a lovely experience this is. This wire here is basically what? Is this fixed? Is it fuck fixed? I can pull it out. What garbage fucking bad joke this is, for fuck's sake. Should we use the black one? Maybe I should have used the other black wire, maybe. Ah, fuck it. I'll remove this then. God damn it. Cut the thing. I'm going to suck my own cock here. Like, what is this? Like, is this a fucking bad shit joke? Like, honestly, come on. Like, for fuck's sake, I want this shit to be put under this fucking pin. Go under it, you utter fucking cunt. Why can't you cooperate? Fucking hell. This is a bad joke. Yes, this is a bad joke. A very bad one. Please, for the love of fucking God, work. Finally. Oh fuck. Oh, for fuck's sake, come on. Sort of okay. Which is the longer one? This. So this will go to here. Then you fucking go onto the pin. This will go on here. And then great, whatever, and then we have the PWM pin, which is the next one, PWM in, which is, I suppose, either this or that. I have no fucking clue which is which. Let's see. Which pin is the PWM? PA6 goes to the blower, which is PA6. PA6 is the one that is more up. Yeah, that is the blower. Okay, good to know. So the upper one is the blower, which is the green one. The green is the blower. The green is the blower, and that is the blue one, which comes right here, the blue one. Okay, we have all three connected up. Lovely. We need the other one, which is going to be this one. Just coming under these. So what's up, Mace Finger is here building the burners. What is this? Currently building the burners stuff. I do not know if I could technically. Oh, I made it crossed. Oh fuck. Oh, come on. Come on, go on to the pin. Aye. Please. God damn it. Oh, I think these have some resistors in them or some shit, if I remember correctly. I really hope I got the right ones. I think they have the resistor here soldered onto them or some shit. Oh no, the PWM wires have them. Oh yeah, I remember now. PWM wires have actually this. That is why they are special, because there is like one resistor here that is soldered onto the end. So yeah. Okay, that is fine. We do need the thing here. Where's the pressure sensor? Hello. I think I can remove this. So oh, I forgot. Yeah, this fucking daisy chain shit. Well, technically I could have made it shorter. Voltage divider, which means that we put the signal either in here. I think that here is the cap, and well, no, here. So basically we have the signal in here, and we take this sample from here, which will use, I don't know, what did I use this for? This is need another wire, a white one or some shit. Blue is fine as well. This is going to be the pressure sensor. And this is basically like negligible connection, pretty shit, meaning this will be fine. Though probably not the best idea to put it under all these fucking wires, going to put it onto the top. Here, next to the ground wires, has some shielding at least. Nothing. This is a bit more tight. Okay, these will be the wires that we need. We will need to tuck them under. These will go to the right to left. From right to left. What is this? So right to left. So from right, oh, which right? Oh fuck. But I think the right one was when I was looking it. So if it was, yeah, it was that side as well. So it was then. Fuck me, I can't remember which direction it was. Have to look at which is which. So, which is which? The off light. So, how is this? Straighten out. So the shitty wire is the 0. Or no, this is the 2. The shitty wire is the 2. Which is the last one. P. What is that? The last. On the outside. MX. Last on the outside, which is... Oh, fuck's sake, it's the last. PC3. PC3, what is PC3? Deer. Which is the deer? It's exactly on the opposite side of remote. So is the top one. Deer. That is the middle one this is the last. So 0 is the leftest, yes, so the 0 is the left. So 0 goes to, yes, to here is the single wire. Zero, one is the second, comes here, some sort of tool to push it onto the pin. And the second is the last. Okay. I mean, it's a bit more tidied up. That's for sure. We'll steer the ground and put it, yeah, steer the ground and steer the 3.3 volts. I need them up the whole board. A bad joke. Yes. I was not the finally. Okay, so the ground and 3.3 volts. I will remove these. So this will be removed. This will be removed as well. So the ground can be taken off of here. Ground cable. Not good. Oh, for fuck's sake, we don't have it. Not good either. Ground. Female. Yes. Let's see what we have here. Please be the ground. We have purple, that's good. We can even use that because we will need the 3.3 volts. 3.3 volts will be taken from here. I will steal it under this cluster next to these and take it. So the ground will be connected to here. 3.3 volts will be connected to here. Lovely. So we have these here, no matter. We have these here. So we have now the ground. Ground is common. Good. We can take the ground from here. We can take this off. It's true. We need to replace the ground from this. Okay, my knife. Knifey, hello. Hello. So, cleaning up the cluster fuck of these wires. What up? What's going on, man? Tell me something interesting. Or it's even fine if it is not interesting as well. How was your day? Or anything? And ground. The ground pretty great. I do think we do have a few we have these crushed balls as well. And this is the crushed one. I need to find myself a pin for this. Pin, pin, pin. Pin, pan, pin, pin, pin. Oopsie doopsie. LN 298 more. Oh, back is breaking off. So maybe this. Yes, red one. Okay, so what do we use? The purple. Yes, we use the purple to the 3.3 volts. Why is this so fucking loose? This is basically like loose as shit. this is better. Okay, going to jump the wire across. These are irrelevant. Oh, great that you wanna leave a yeah. What is the arrow? The arrow is this one. What is the signal? I think this. And this is the signal. The arrow is the signal of this. I remember. Yes. These will be used. This will need to come under. Tug them under. So VCC. Oh, great that you leave a great. G and D. Yeah. I mean, technically we can use this. Here. And we can jump it about. Hello. And we're going to put the jumper here. Good. So purple and this. Maybe I should have bought some fucking yeah, sure. So basically this is a burners that I built by the control board. We can here see in the top the two boost bars that are the ground and the 12 watts. These are powered from an external power supply that is there. And that is there. Whatever there. And yeah, I usually use that to power because you need a lot of power to run the blower, about 40 watts. And that's not a lot, but in terms of like DC 12 watts, it is kind of a lot in amperage. So that is the blower, feeds the blower, and it feeds also the pump as well as the choppers. Well, very brief intro. STM32 here is the brain of the whole operation. We can control him, and it is interactive. It will be automated later on, so that it will do its own thing and control the burner by itself, based on the desired steam or whatever we want to use. Leave it that. So basically, he's the brain of the operation. He runs the whole thing. From him, we can control the MOSFET board, which is the chopper here. We have two separate boards, the separate MOSFETs that the STM32 controls, and with these we switch the pump and the blower. The pump and the blower provides the air for the burner, the pump provides the fuel for the burner. This is a fuel pump. Both are 12 volts. As I said, the pump, or the blower, which is a bigger one, this side, which is also rated for 24 volts. This is probably not, because the shotkeys are also rated for 12 volts. Or only rated for 12 volts. I think it is like 1.1 watts for the pump, and about 36, 37, 8, 40 ish watts for the blower in total, as well as like the chopper things here. This is what I have been doing today, basically soldering and finishing the whole thing. This is a protoboard that is condensing everything into one unit. That is fine, kind of final, and soldered and all that kind of stuff. Has a lot of jumpers and all that. Made a lot of little wires. You can't really see it. I will give. So basically, here we have a lot of little black wires. These are from the ground, of course, 12 volts, and you can see the two little green boards. These inside are the MOSFETs switches. Basically, the STM32 sends out the PWM signal that we want. Basically, we can control the blower and the pump in the 0.1% range with them, and this does the low side switching that basically sends the MOSFETs at the PWM. Basically, we take 3.3 volt PWM, and with these we make 12 volt 12 volt PWM out of it, and that 12 volt PWM is enough so that the MOSFETs don't get fried, because when you apply voltage to it in the beginning, there is like linear ramp up when the resistance drops to a certain point, and basically when you need to get out of that, because there is a lot of resistance in the saturation zone, and that is where you kill your MOSFET on a low PWM, because it starts to really heat up, and then after you reach like 80 degrees or something, which is the limit for the MOSFET, then you basically kill it. And I have done that, and killed the 12 volt side. So basically this had to be replaced, and the 24 volt side didn't, because probably the I didn't use it too much, plus the bulkier shotkeys and all that kind of stuff probably saved my ass, as well as I didn't run the pump, because I would use the pump, and yeah, I mean this was total. And also we have a another thing, which is the compressed air. The blower is not enough in itself. We need to atomize the fuel, and we need to break it up into fine droplets, which is using a compressor for now. Maybe we'll use steam later, but the main point is that the compressor is driven from this screw here. This, fuck, we'll need to get it out. And that is the stepper air screw, as I call it. Basically it is a diaphragm thing. It is a diaphragm. This gauge doesn't work by the way, so this is a diaphragm, and the stepper air, basically a stepper that is controlled by the STM32, and as the stepper is controlled, we increase or decrease the amount of compressed air that gets into the burner and breaks up the fluid or fuel, depending on our needs, and we can adjust the amount of air and the pressure of air with the thing. This has like a feedback to it, but that's irrelevant for the point. So yeah, this was it in a brief, very brief intro. I probably could have done a bit shorter, but I don't know. Are you still here? Do you have any questions? All that kind of stuff. So I don't know. Do you have any questions about that? I will now continue. You can put it into the comments. I read the chat whenever this is. So. want to put the same things together. Okay, we have this, which will be the firewalls. What is this? Well, I think this will be the new thing, the new stuff, which is going to be this. We will put the or I think this is debug. Yeah, because yeah. We'll be able to do this. Okay, fine. We can remove the clicks. Hello? Oh, is this a fucking bad joke? Hello, what up? Oh no, I put it in the wrong direction. Or was it already fucked? Maybe it was already shit. I need to take the guy out. I will need to eat, for fuck's sake. And I think the yellow was trash actually. So we need something. What is this? Orange. I don't have any oranges. Fuck. Where is this? Oh, here it is. No worries. No worries. No worries. Have no fear. Don't push. Okay. Okay. Okay, fine. So, if I am correct, we should put the Doitsy. Should sneak through here or around. Maybe around. Maybe around here. And around we go. So basically we can remove the bubbles completely and utilize this yellow here next to the white. Use this orange, we need to find some pins for this. This is trash. What we need? We need a... What color did we use for this shit? I really hope these are not fucked. I need to see. I have a bad feeling about this. Yes, this is probably shit. Yes, this is garbage. Great, I need to clean this as well. Of course, of course. Come on. Which one is this? The other one. Oh, need a few pins exactly for, to be honest. Exactly for. No, not even going to put this away. So. Oh! Okay. Alright. Alright. What do we have here? We have the red one. We use that for the 5 volts. The 2 5 volts actually, we need two of the red ones, and I suppose this one is damaged as well. Yeah, it looks pretty garbage. And this will not be used to anything. Very trashy. Not squished. And what up with this? Got that as well. Great, good to know. Do we have any? This is mail, for fuck's sake. Don't have a goddamn fucking proper. Oh, this is garbage as well. Fucking hell. Shit, fuck the wires. Oh, not good. Put the pins on at least. Hope I will. Hello? This does not look too... Yeah, it doesn't look bad. What up with you? Go on. Go on. Yay. Hello? Very tight. Yeah, I mean, I don't mind it. I don't mind it. This is the trash. Yeah. How do you want to get this out to this? I think we can do it under here. We need to take this off. Replace the wire with this is off-white. I don't think I have any off-whites at hand, at least. Do I have it here? Let me search with my hammer here so that they are not damaged. This is cracked completely. This doesn't even have an end. This is fucked as well. Nothing good. Nothing optimal, I would say. Switch these fucking silver wires. Whatever. This is which is this? This in between the green and the orange. If I can put it in. Come on. Hooray. We have got him. Right, this is not good either. Can throw this into the trash probably. Where is our off-white? Here. Take it with the orange here. In the back garden. And put it here. Oh, I see what the problem is. Well, at least it doesn't. Okay, red wire. Green. Thankfully, we can. I mean, I can put the red wire to the back off. Oh, is this on? It's not too tight, let's say. Oh, what a great... How the fuck is this done? Oh. Honestly, disgusting. Disgusting. Shit fucking wires. How is this... how the fuck is this done? How is this done? Not properly and odd. I got that. Where is it? $49. Finally, at least better. fucking signaling them. Yeah, it was red for the 5 volts and purple for the 3.3 volts. So we have these two fuckers. We have one here. And we have one here. back is killing me. Come on, go through the fucking hole, prick. Technically, if I really wanted to be very fancy, I do have this thing I can put. I have 60 pieces, it appears. that I have 60 pieces of this 2R. These are like 2 long connectors and a bit bigger than the normal size ones, but nonetheless, or we can connect them together and this way we will be able to take them off. What a great experience this is. Why does this not come out? This is probably ruined by now. Great. At least we now know. We need to put the one in. Of course not the right way. Great. Finally. Click them. Okay, good. Hallelujah. So much so hard I struggle with the one wire or one-ended connectors. Can't even push this shit in. Oh, fine. Still here. Good. Started to use these. I don't know. Maybe no. Maybe not. Fine. Put these together. This should not be under it. Yeah. Yes, this should not be under it, but over. This is just an honest struggle against the chaos of wiring. Oh, great. So much so for the fucking wiring. What a great wire. Hey, dickhead. How about this? Ooh, fuck. Oh, overdone it. Fucking hell. Fuck the thing. I have fucked the thing. Not so bad. This time it's a bit more tight. Alright. Fucking. Whew. Yeah. Takes up a long time. Cluster fucking cluster of wires. I need the ground pin as well. This good fella. These are all shit, let's say. Shit. Let's use the brown. Oh, what a good job. Fucking using the brown pin. Yeah, purple to purple, brown to brown, and brown to. What a garbage shit this is. Finally, a bit more tight. Alright, so we have this one here. And the other one is going to be black one. Black stone. Steven Schwartzman. Hey, fuck off. The box is getting squished. Doesn't have any integrity anymore. Not too good. Is this a joke? Basically my nail is getting chipped off rather than the pin going onto the fucking place it's supposed to. What an experience this is. Oh! basically just ruined the clip. Oh, great. Now, then replace the clip with another one. Might I try it on? I think it is good. No, the pin is shit. It's a bit tight, to be honest. Hopefully it will not be anymore. I'm a bit skeptical about this. Oh yeah, it is working now, fine. Okay, so this is the minus. Yes. Yes, this is the minus. Alright. Oh. Big amount of work has been done. A great deal of work has been done. Almost done with everything except the one thing, which is the wire, which is this. This wire. Tomorrow I will double check everything. Work a bit on the. Basically, barely have any females left. To buy a new set soon. We still a lot of them. Oh, these are a bit wanky. So I think this was it. So everybody, thanks for being here. If you watch this back, it was me, Swinger, and we did a lot today. Wired a lot of wires. Did the protoboard. You probably can't really see it from this picture right now, but did a pretty good job with that as well. I think this was a pretty good day. So yeah, thank you for watching. Tomorrow we will continue from here, taking the wires together, and then also adding the wire for the feedback for the air screw. And then we are going to test everything, double check the wires, then test everything out, and then debug the thing as well. Yeah, that's it for today. Thank you for watching. My Swinger is out. Goodbye. Let me check one more thing in the Alright, so yeah, that's it. Thank you for watching. Do the hard work, especially when you don't feel like it.